Welcome to a lesson with Dr. Powell. Let's take a look at limits that deal with infinity. So let's start with an example. F of x is equal to 2 plus 1 over x. And let's look at the limit of f of x as x approaches infinity. What in the world does this mean? Well, if we draw this graph, this is actually the graph of 1 over x shifted up by 2. So you have an asymptote that goes like this, and it looks something like this. And graph that goes back like this. Okay, now what we're doing is we're trying to see what does this get close to as x goes off to infinity. Now, if you wanted to use the analogy of hole filling, we could like infinitely compress this axis in, so all the numbers from 0 off to infinity are compressed into maybe an open interval from 0 to this point, just kind of like an infinite compression. Then at this point, it would not be defined at the end, but see how there's this asymptote? The numbers are getting closer and closer to 2. It would be as though there would be a hole, and it would come off there where the input would be infinity, if infinity happened to be a number. And so then we could think of it as hole filling by just filling in this hole. And what's the y value that fills it in? Well, it's 2. Just a little thought experiment. But in general, it's the same idea. It's a hole filling still. What y value is the function getting close to, so it kind of looks continuous. Notice how this is a one-sided limit. When you're going off to infinity, it's one-sided. We're not going from two sides. There's only one side to head toward. Likewise, for the exact same function, if we went the other way, the limit is actually also, in a similar sense, also equal to, if we were to fill in the hole here, the value would be 2 to fill it in. So the limit as we go, the limit of f of x as we go to positive infinity is equal to the limit as x approaches negative infinity. In this case, is equal to 2. This is not always the true for all functions, but for this particular one it is. And so that is a statement there for a limit that goes out to infinity. Now, let's take a look at another example. If we had f of x is equal to sine x. Now, if we did the same kind of infinite compression, think about what would happen. When we compress it infinitely, it would oscillate up and down so many times, we wouldn't know where it's getting close to. It wouldn't be getting close to anything. Therefore, this limit, as x approaches infinity of sine x, does not exist. Okay, now let's look at a one-sided limit. 1 over x minus 2, and take a limit as x approaches 2 from the right side. All right, now we know there's a few things we know. One, this is a transformation or a shift of 1 over x to the right 2, so we know that the graph will look something like this automatically. And so what's happening here, as we go to the right, it looks like the limit is plus positive infinity. Wait a minute, were you saying we're letting infinity be a possible output? Yes. We're not going to say it doesn't exist. We're going to say it actually is positive infinity because it's a real idea. This graph really is going up there in that direction. And if we were to infinitely compress and put infinity on the end as an endpoint, there would be a hole here because it's not defined. Infinity is not because this idea is 1 over 0. I mean, that's not defined, but it's getting close to it. From this side, we can fill it in, and that would be the output, positive infinity. Likewise, if we had a graph going down on that side, what if we took a left-hand limit of the exact same thing? We'd actually get negative infinity. However, if we take a limit as x approaches 2, Notice how the left hand and the right hand don't match? Then we just say does not exist. So we can still think about limits outputting positive infinity and negative infinity, and for the limits existing. However, this limit will not exist because we're going up that way to positive infinity and down that way to negative infinity. This is one of the reasons why we can't just simply say 1 over 0 is equal to something, because 1 over 0 written this way, is it equal to positive infinity or negative infinity? Because you can approach it from two different sides, from this side or from that side, and you don't know which one if you're thinking about 1 over x and thinking about x being very small. Hence, there is really no nice way, continuously at least, to define 1 over 0. But you could define 1 over 0 plus on the right side, where you're only taking 1 over something very small that's positive, or 1 over something very small that's negative. Those are possible to define, but 1 over 0, just the way it is not. Thanks for watching.